Mm, mm, mm,
Hi everyone, good evening. I think I'm audible to all of you. Can you please confirm in the chat, guys, if I'm audible? Hi. All right, so we can start the session and welcome to day 7, guys. So today I'll show you how we can train CNN, okay, from scratch on top of the custom data. So far we have learned like convolutional neural network. I showed you like different component of convolutional neural networks. Okay. Even I already showed you how we can implement with the help of code. Okay. I use TensorFlow to implement the entire architecture. Even I also showed you some predefined architecture like Linet 5, then AlexNet. And now we are ready to train the model, guys. So here I'll show you how we can create a custom architecture, and we'll be taking a custom data set. Okay, on top of that I'll try to train the entire model. Even I will also show you the prediction. Okay, evaluation and prediction. Okay, both I'm going to show you. And today I'll also try to discuss, like, see, if you're using these kinds of like from scratch model, like custom model, what would be the issue at the end? Okay, why we have to use the transfer learning approach? So this thing I will also try to probe in this session. Okay, so if you're new to my channel, guys, so this is the playlist computer vision for developers. So here we have already completed till day 6. So if you are joining for the first time, first of all try to check out the previous session, then you can continue from here. Okay, and if you haven't subscribed yet, guys, so please try to subscribe, and if you like my session, please try to like the session as well. And please also share with your friends and family so that they can also get to learn these kinds of amazing content. Okay, so fine, so I think, guys, we can start. So first of all, here I'm going to show you the data set I'm going to use, guys. So here we'll be implementing a image classification architecture. So let's say here you will be having some image, and you will try to classify whether this image is a this category or this category. Okay, so these kinds of project will be developing with the help of CNN architecture. And for this, the dataset, guys, I'm going to use. So this data is already available over the Kaggle. So the name of the data is apples or tomatoes image classifications. Okay, so here what we have, guys, we have some images. Okay, you can see we are having the tomato image, and we are having the apple image. You can see we are having the apple image and we are having the tomato image. Now we'll be implementing a model. We'll be implementing a CNN model that will classify whether this particular image is an apple image or this particular image is a tomato image. Okay, so this particular system will try to develop from scratch, and this is the custom data. Okay, so see, I'm not going to use any kinds of like MNIST data, handwritten data, because at the end this is just for only for the like demo purpose, learning purpose. I'm going to work with the real time data, guys. Okay, because see, here this series is for the development. Okay, this series is for the professional development. So at the end you have to work with the actual data, actual real image. So most of the, let's say, training I'm going to show you, I'm going to use real time data, and I'm going to show you in that training. Even I will also show you how we can convert it to the applications, application level like design. I'm also going to show you. Got it? Yeah. So I'm not going to take any kinds of dummy data set, guys. Okay, like MNIST, handwritten, fashion MNIST, I'm not going to take that, because at the end you are not going to use those data. Okay, but instead of that, if I take the real time data, real time image, so this will help you to understand. Okay, this will help you to understand how things work in the industry. Okay, let's see, if you are getting a problem statement, if you are getting the image, so how you can let's say build the entire system. So this is my objective. Got it? Yeah. So first of all, guys, what you can do, you can download this data just to test how many folders you are having, then how many image you are having. Okay, even it is already available here. You can see, you can read the entire data description. So here you are having, see, the image of tomato and apple collected via web scraping. So they did the web scraping. These two fruits have been chosen because they look similar, and so should be challenging classify, because if you see the tomato and apple, okay, so both looks actually same. Okay, if you see both looks are same, that's why it would be a little bit challenging for us to classify them. It would be a little bit challenging for our model to classify them. Okay, that's why we're taking this problem statement. So images of red, yellow and green apples, tomatoes have been splitted into train and test sets. So here you can see, guys, I'm having the training folder as well as the testing folder. So inside training folder I have apples and tomatoes. So inside apple folder I'm having the apple images. Okay, then inside tomato folder I'm having the tomato images. So similar wise in the test folder also I'm having the apples, then I'm having the tomatoes. So that's how you have to define the folder structure. See, in image classification, how we annotate the data. Yeah, I will tell you, no coder. I'm not going to download it, and I'm not going to use it from this Kaggle itself. Instead of that, what I will do, I'll show you one approach. So in the Kaggle itself, you can directly, let's say, take the data. Okay, I'm going to show you this part. Can we include this project in our resume? I'm computer engineering BA student. See, just wait for some couple of session. Okay, the other peer. So after a couple of session, actually, once we have learned transfer learning, now, so I'm going to show you some more good project. Okay, so don't add this particular project on your resume, because at the end, see, here we'll be using the custom architecture, and we don't use the custom architecture in the industry. Okay, so better just wait for some few session. And once I start the transfer learning, that means we'll be using the pre-train model, right? Pre-train architecture like Alex, VG16, ResNet 50, Inception. Okay, these are the model. That time I'll take some good problem statement, and I'm also going to show you how we can create the user interface also of your applications. Okay, that means end to end we'll try to develop everything. That time you can add those project in your resume. Okay, just wait for some few session. Don't add this one, guys. Yep. So see, first of all, I'm going to download the data just to show you, okay, what is the folder arrangement. So see, I already downloaded the data. This image, I think I downloaded already. Let me check. It is available in the downloads archive. Okay, so let me unzip it. See, if you just click here, download, it will download as the archive.zip. And if you want to download it, first of all, you have to create one account in the Kaggle. Okay, you want to if you want to download, you have to create one account in the Kaggle. Yep. And the dataset name is apples or tomatoes image classification. You just search with this name, you will get the data. See, if I search on Google, na classification, now if I search, see the first dataset, okay, you can open it. So this is the data, guys, I'm using. Otherwise, I will also share the link in my GitHub. So I think link is already mentioned in my description, guys. So all the materials I have already updated. You can see till day 6 I have updated everything. Okay, so whatever code I'm going to use today, it would be also updated in the day 7. So first of all, let me unzip it. So see, this is the unzip directory. Now see, that's how my data is structured, guys. Okay, see, if you are having any kinds of data, let's say you have your own image. Okay, let's say you are having your own personal image. That time, how you have to prepare the folder structure? You have to prepare the folder structure like that. First of all, create a train folder, then test folder. So inside train folder, you have to keep the training images, guys. Okay, now how many category you are having? First of all, you have to identify. Let's say here I'm having only 2 category. One is apple, another is tomato. Okay, let's say you are having another fruits, let's say orange. So that time you have to create another folder, and inside orange folder you have to keep all the orange images. Okay, now let's say you are having jackfruit, then you will be creating another folder called jackfruit. Then inside that you'll be keeping all the jackfruit images. Okay, so how many category you are having, based on that you have to create the folders. So in this case I'm only having 2 images, 2 category, like image apples and tomatoes. Okay, so that's why I have created 2 folders, apples and tomatoes. And inside apples I kept all of the apple images. You can see I kept all of the apple images. Okay, like you can see red apple, green apple, yellow apple, I have kept everything. And total you are having 164 items here. So here we are having less images because I want to show you the training demo, that's why. But whenever you are training the actual model, okay, whenever let's say you will be developing the actual project, that time you will be having lots of data, you will be having lots of images. Okay, yeah, but just to show you I'm using less image because it will take time whenever we'll try to train the model. So training usually takes time if you're using free GPU, so it will take time. So that's why I'm taking less images just to show you the training process, okay, how training can be done. But make sure whenever you are training your actual model, just try to collect some more data. You can scrap some more data. See, this data they have collected by the web scraping. You can scrap some more data and you can increase the data size. Got it? Fine. And in the tomato folder, guys, I kept all of the tomato images. You can see, so red tomato, green tomato, as well as the yellow tomato. Okay, now you can see these two categories are close to each other. Okay, tomatoes and apples both are almost same. Okay. Now this is what my training, and in the test folder I again created the same folder structure, guys. You can see apples and tomatoes, and inside apples I kept all of the apple images, and I'm having 54 items for the testings. Okay, testing images, because see, once we train the model, we also need to evaluate the model on top of the test data. So that's why testing set you have to keep it different, okay, apart from the training set. And in the tomato you can see I'm having all the tomato images. So this should be the folder structure, guys. Okay, always remember this is the folder structure for the image classification. Any kinds of image classification you'll be doing in future. And if you're having some other category, you have to create the folder with the name of that particular category. Don't create like 1, 2, 3 like that. Okay, so always try to give the name, proper name of the category. All right, now either you can upload this data, guys, either you can upload this zip file on your Google Colab. So let me open up my Google Colab. Otherwise, if you're using Kaggle, we can download this dataset from the Kaggle itself with the help of code snippet. Okay, I'll tell you how to download it. So let's create a new notebook. So I'm going to name it as training CNN from scratch on custom data. Now here we'll be training the model, and this is a deep learning architecture, guys. For this you have to select the GPU. So change runtime type, so GPU. So T4 GPU I'll be taking because I'm using free Colab. So let's take the GPU. So the first thing, guys, we have to download the data. So before that, first of all, let me add the dataset link. So data link. So here is the data, guys. I'll copy and let me paste it here. Now, see, if I want to download any data from the Kaggle, guys, first of all, you have to get a access token. How to get the access token? So what you can do, you can go to your profile. So let me open up my profile. Go to the profile, go to the settings, and below you will see one option called API key, guys. Okay, now here you can click create a new token. Okay, create a new token. So if you do it, it will download a JSON file. So let me show you. If I do it, see, it will download a JSON file, kaggle1.json. So previously I already downloaded one. Okay, that's why you can see Kaggle. So let me delete everything and let me download freshly. Let me refresh. Now create access token. See, it will download a JSON file. Okay, now this JSON file you have to upload inside Google Colab. How to upload? Just right click and upload and select that file and try to upload it here. Now if I refresh, so this file would be available. Okay, let me do it again. So see, Kaggle JSON is available. Inside that you have the access token. Just a minute, guys. All right. So now what I will do, guys, I will show you how we can get the data. So for this, you have to execute these two commands. These two commands you have to execute. First of all, you have to create a directory called .kaggle. Okay, and inside that you have to copy this JSON file. You can see I'm doing the copy operation, CP. Okay, this JSON file would be copied inside this directory. So let me execute. Now here I'll be executing one command. So this is the command, guys. So Kaggle dataset download -d. Okay, now you have to give the dataset ID. Where you will get the dataset ID? So see, this is the URL, na? So here till here, this is the dataset ID. After dataset, you can see the username, and this is the dataset name. This is the user dataset ID. I'll copy, and here I'm going to paste it. Okay. Now if I execute, it should download the data. See, it has downloaded. Now if I refresh, see, this zip file has downloaded. Now I have to unzip the file. To unzip it, just write this command. So unzip. Let's copy the link, copy the path, and execute. So see, it has done the unzip operation. Now if I refresh, see guys, your training folder is available and testing folder is also available, and inside that I am having my tomato as well as the apple. See, got it? So that's how easily you can download any kinds of data from the Kaggle itself. Please explain backpropagation in convolutional neural network. Yeah, I'll be explaining that part also. It is in the pipeline. Okay, real animation. Why it downloads in less amount of time from Kaggle to Colab as compared to the downloading from Kaggle to our local storage? See, because see, the dataset is like not that much huge. Okay, you can see it is around 2.42 MB, around 3 MB. Okay, that's why it took very less time. Got it? Sir, please explain backpropagation in convolution. Definitely I'll try to explain that. Okay, yeah, everything I'll try to explain, no need to worry. So let me go with my flow. So I think then I can explain the things better way. Okay, so I have the flow always. Okay, that means the teaching flow with any kinds of courses. So let me follow my, let's say, path. Definitely I'm going to cover each and everything, whatever you need. So now what we'll do, guys, we'll try to import some necessary library. So I think I showed you guys, we use these are the library, right? So previously we also used these are the library like TensorFlow, Keras, then sequential layer, then dense layer, convolutional layer, max pooling layer, and flatten layer. Okay, yes or no? Because this thing I have already covered in my previous session. If you haven't checked it out, please try to check. Okay, I'm not going to repeat this part, guys, because I already explained what is dense layer, what is convolutional layer, what is max pooling layer, what is flatten layer. Everything I have already clarified. Okay, so let me import them. Now the first thing, we have to create the data loader, guys, because this is the custom data. This is the custom image, right? So we have to create the data loader. That data loader will try to load the data. Okay, and it will make the generator object. So how to make it? So let me just comment here. We'll be creating data loader right now. So to create the data loader, guys, we'll be using Keras. So inside Keras, you are having a function. So let me just import it. Keras dot utils dot image dataset from directory. Okay, image dataset from directory. Now inside that you have to pass the directory first of all. Directory story is equal to what is your training data? See, this is my training data. First of all, we'll be loading the training data, guys. Okay, training data set. Train data set. Okay, and this is the train data set directory, guys. Just try to copy the path and here just try to mention. All right, then here you have to convert. Okay, you have to convert this category to numerical representation, because see, here I'm having the text name like apple and tomatoes, right? But I can't pass this, let's say, category to the model because this is an English text. I have to convert it to the number. And if you want to convert it to the number, guys, you have to define two parameters. One is labels. Labels is equal to, you have to write it infrared. Okay, infrared. Okay, infrared. And there is another parameter you have to mention called label underscore mode. Okay, label underscore mode, you have to make it as int. That means it would be converted as a integer encoding, guys. Okay, integer encoding. I think you already know what is integer encoding. So how it will let's say convert. See, in the folder, you can see in the folder which category is coming at the first as a alphabetical order, guys. Definitely apple. That means apple would be converted to 0. Okay, and then tomato would be converted as 1, because this is the second see 0 1. Okay, it is following the order, guys. Now let's say you are having another category. Okay, alphabetical category. So that would be assigned as 2. So that's how this integer encoding works, guys. Integer labeling works. Got it? So don't be confused, guys. Okay, see, always try to see in the folder which particular file is coming at the very first. So this will assign as 0, then 1, then 2, and so on. Okay, you can follow always alphabetical order, guys. Okay, alphabetical order. So let's say later on, if your model is predicting 1, that means it is predicting tomato. If your model is predicting 0, that means it is predicting apple. So always try to remember this category. So let me comment here. Tomato would be 1. See, this is the Keras parameter. Okay, they are telling if you want to convert it to the numerical representation, just try to make these labels as infrared, and label mode is equal to int. Okay, no coder. You can go to the documentation, you can check it out. Okay. So let me comment it here. Apple 0, tomato 1. Okay. Now you have to also define the batch size. Okay, why batch size is important, I'll tell you. So batch size, BATCH underscore size. So let's take 32. You can increase and decrease as per your machine configuration. Here we're using free collab, that's why we're using 32. Okay, 32 batch size. And here you have to specify the image size, because see, you have to fix the image size, otherwise what will happen, let me show you. So see, always try to take like 2 to 4 comma 3, otherwise you can also take 2 to 4, sorry, 2 5 6. Okay, 2 5 6 comma 2 5 6. So this particular dimension you can always take, otherwise you can also take 2 to 4 comma 2 to 4. Okay, this dimension you can also take. See what is happening if I open my image now. So all the image is a different dimension. So let me show you. So let's say if I open this apple image, so see, this is the dimension of the apple image, very small. Again, if I move that, this is another apple. Okay, this is another dimension, then this is another dimension. See, some of the image is bigger, some of the images is smaller. This is the issue, guys. Okay, to prevent this issue, first of all you have to define a fixed size. And how you can define? So here you can define image size. Image size is equal to 256 256. Okay, I have defined 256 256. That means image width would be 256, image height would be 256. Okay, this is the idea, and everything taken care by Keras itself. Okay, Keras, this function you are using na, image dataset from directory, it will try to take care everything. You don't need to write that code from scratch. This is the advantage to use the Keras. Why batch size is always an even number? Because it came from research. Actually, they're telling if you're taking the even number, so it will work better in the, let's say, hardware, because at the end it will load the data in the memory na, and memory is nothing but hardware, and it will try to do the calculation on the CUDA. Okay, CUDA core in the graphics card, right? So that's why. Fine. Okay, so these are the parameter, guys, you have to define whenever you are loading any kinds of data. Now what happens, see, why we have defined the batch size? Because see, if I'm not defining the batch size, what will happen? It will try to load the entire data in the memory, during training. And if you're using, let's say, very low configuration memory, let's say if you're using 8 GB RAM, or let's say only let's say 4 GB RAM, that time what will happen, your memory will get crash, because it will try to load all the image in the memory as a matrix form, and I think you know that matrix will take lots of space in the memory. So that's why we don't want to load the entire data in the memory. Instead of that, we want to load as a batches. Some amount of data will try to load, will try to train. Okay, and again once those data is got trained, again I will take another batch, I will again train, again I will take another batch, again I will train. Okay, that's how we'll try to train the model batch by batch, so that these kinds of memory issue I won't be having later on. Okay, that's why batching is super important whenever you are training any kinds of model. Okay, whenever you are training any kinds of model with the image data, not only image data, it is for the let's say text data, it is for the tabular data, any kinds of data if you use, you always load the data as a batches. Okay, I think you already know batches. Okay, you have already learned in this thing in the machine learning. Yes or no, guys? Yeah, got it. Fine. So this is this particular code will try to load my training data. Now I also need to load my test data, so I'll copy the entire code and I will make it for the test data. So here test data, I can make it as validation data, validation data set. So here I'm going to give that directory. So this is the directory I'll copy and let me pass it here. Okay, so this is the validation directory, and again it would be infrared and int 32 256 256. Okay, everything is fine. Now see, if I execute the code, guys, you will see that automatically it will try to load the data from the folder, and it will show you the count. See, found 294 files belongs to 2 classes in the training set. Okay, now if you open the training set, so if you see the Apple folder, guys, see, if I show you the training set, and if you see in the Apple folder, here you are having 164. Okay, 164. So let me open up my calculator. So 164 plus, okay, if I show you the tomato as well, again 130. So 130. Now if you do it, you will see 294. Okay, that's why it is telling 294 file belongs to, okay, training let's say folder, and 2 classes. That means you are having apple and tomato only. Now for the testing, see, this is for the training and this is for the testing. Now in the testing also, if you count, let's say apple, here you are having let me clear 44 sorry 54 plus in the tomato you are having 43. So 43. Now if you add it, okay, you will be getting 97. Now that's why it is telling 97 belongs to in the test folder, which is having two classes only. Okay, you can also make it as test data, but see, whenever we do the validation, now whenever let's say we try to evaluate the model, we call it as a validation. In I mean in image classification, in programmatically we call it as a validation set. Okay, not the testing set. That's why I named it as a validation DS. Okay, you can also name it as test DS, but it's completely fine. It's just a naming convention, that's it. Hmm. So my data is loaded. Now if you see, this is the object, this is a generator object, guys. Okay, this is a generator object. Now if you perform iteration on top of it, that means if you apply for loop, then it will give you the data. Now see, one thing I have to do, I have to normalize the data, because if you see any kinds of image, any kinds of image, so let me import a image. Let's say I'll take this image having the number, I think here. Let's take this image, guys, as an example. Now see, if you see any kinds of image, but again this is a normalized one, but I need without normalization. Let me import another image. Okay, maybe I can do Google search. MNIST image pixels. Let's take this data. I'll copy and take it on my board. Now see, if you see the number, guys, this number in the pixel, if you see the number, this number is 0 to 255. 255. Okay, 0 means this is the black pixel, and if you see the number, it's a white pixel. That means the number range is 0 to 255. Okay, any kinds of images, if you are considering the color image or black and white image, black white image, okay, all the images having the same range 0 to 255, guys. Okay, now 0 to 255, I think you can see this number range is a different range. Yes or no, guys? This is a different range, right? So what will happen whenever we'll try to train the model during backpropagation, it will have the difficulty to find the globa minima, right? So that's why what we need to do, we have to normalize that to 0 to 1. To 0 to 1. Okay, now I think the previous example, now I think you can see this particular image has done the normalization operation. Normalization operation. That's why this number is 0 to 1. You can see this is 0 to 1. You can see 0 to 1. So normalization, have you learned, guys, in machine learning? Yes or no? Pranjal is telling I'm late. Hi. Yes, hi Pranjal. Hello. So have you learned normalization, guys, in machine learning? So I think you already know what is normalization. I don't need to explain that. That means you are bringing the numbers in the same range. Yes or no? In the same distribution. This is the idea for the normalization. And why we have to do? Because we can see the image pixels we are having, it is having different range. That means 0 to 255. It's a huge number, right? You can see 0 and 255. It's a huge difference, right? So that's why we have to do the normalization. We have to bring the data into 0 to 1. Okay, 0 to 1. This is our idea. And how we can perform the normalization? So here I'm going to write a function. So this function I have already written, guys. So see, this is the function I have written. So let me just comment here. We are doing the normalization. Normalization. And this is the function. It will do the normalization, guys. So see, it will take the image. Okay, it will take the image and it will also take the label. It will take the image, it will also take the label, and what it will do, it will try to normalize. Why it will normalize? It will try to normalize on the image only. Okay, and label, it won't be doing anything, because see, as of now we are not passing any kinds of label. Okay, as of now we are not passing any kinds of label. We are just only returning as it is. Okay, as it is. That means I have already converted my labels to let's say 0 and 1. Okay, it is already integer converted. So I didn't need to apply any kinds of normalization on my labels. Okay, that's why whatever label user is passing, I'm passing it as it is. Okay, I'm not doing any kinds of processing there. Now see, now whatever image I'm having, image matrix I'm having, I'm just dividing with 255 dot. That means 255 dot means it's a floating number. Okay, it's a floating number. Now if you divide any kinds of image pixels by 255, that means floating 255, you will see that that particular range will become 0 to 1. That means this particular image would be transformed like that. It will normalize like that. That means all the value would be 0 to 1. 0 to 1. Okay, so this is called actually standard scalar, I think. Yes or no? Standard scalar, right? Standard scalar range, if you see that, let me show you. Standard scalar range. It's standard scalar, rescale the dataset, have mean 0 and standard deviation 1. So mean max scalar, okay, sorry, it's not a standard scalar, it would be mean max scalar. Okay, mean max scalar, rescale the dataset so that value falls into 0 and 1. Okay, that means here the processing you are doing, that means the normalization you are doing, that means you are dividing by 255 dot, that means you are doing the mean max scaling, guys. Okay, mean max scaling, and after applying the mean max scaling, your value would be 0 to 1. This is the idea. Got it? Now let me apply on top of my training data as well as the test data. So how we can apply? I can use the map function. So this is the map function. First of all, this is my training set. I am using map and I'm applying this process function, okay, on the training set. The same I'm also doing for the validation set. Now if I execute, see, my processing is done. Now my data Okay, now see, my image has converted to the normalized numbers. That means all the pixels now became 0 to 1, 0 to 1 range, not 0 to 255. So till here guys, clear? Let me know. Are you clear guys? Any question? And this is the same step guys. Okay, this is the like common step for all the classification you'll be doing. No, for loop you don't need to use because map can do the same thing now, and it is easy to use. So that's why I'm not going to use any for loop. And this is a generator object, not at the end. Generator object. That's why we are using the map function on top of that. So maybe you have already learned in Python this generator map function, right? This thing you have learned. For loop you can also use. So that time you have to take the number one by one and you have to do the normalize. But if you are using map, so map will try to do this job in a fastest way. Okay, why? I think you know the map function ability, right? You have learned in Python. Got it? Yeah. Fine. Now we'll try to create our architecture. Now let's define our custom architecture. Okay, custom architecture. So see here, I have already created one architecture. Let me show you. So see, this is my custom architecture guys. Okay, I'm not using any predefined architecture. So this is completely custom architecture. So as of now, let me remove this batch normalization. I'll explain it later on. So this is my architecture guys. See, very simple architecture. I have taken a sequential layer, then I'm adding the convolution layer at the very first, and here I'm using 32 filters. Okay, and the filter size is 3 cross 3. I'm using padding is equal to valid. That means I'm not using any kinds of padding. Activation function I'm using relu. Okay, and the input size of the image it's 256 comma 3 because it's a colored image. Okay, it is having 3 channel. And this is the input size. Okay, 256 because here we have already defined. Now at the second layer I'm using max pooling 2D. That means I'm using the pooling layer guys. Okay, and I already told you max pooling and global pooling is the most used pooling layer in the CNN architecture. So here I'm using the max pooling layer. Now pool size I have given 2, stride I have given 2, and padding is equal to valid. That means I'm not going to use any kinds of like padding. Okay, now how I have defined this parameter, what is this parameter, everything I'm explained in my previous session guys. Okay, just try to check this particular session so you'll try to understand okay why we have mentioned this parameter. Now this is the second convolutional layer. Okay, this is the second convolutional layer, and here I'm using 64 filters, and this is the filter size 3 cross 3. Now padding is equal to valid again because I'm not going to use any kinds of padding, and activation is equal to relu. That means I'm going to use relu activation function for the non-linear numbers. Okay, then again I'm using another max pooling. Okay, pooling layer. Then again I'm using another convolutional layer. Then again I'm using another max pooling layer. That means how many convolution? 1, 2, 3. 3 convolution and 3 max pooling. Okay, then after that we are doing the flatten operations and we are adding the fully connected network. Okay, that means dense layer. So see, this is the dense layer, and here I'm using 128 neurons and activation function relu. Then again I'm adding another dense layer with 64 neurons, and again I'm using activation function is equal to relu. Then at the last layer I'm using only 1 neurons guys. Why? Can anybody tell me why 1 neurons I'm using? So see, the task we are solving, this is a binary classification, yes or no? You have to predict either 0 either 1. Yeah, by default yeah, padding is true. That's why you have to define. Yeah, see, it's a binary classification because you are having 2 category only, 0 and 1. That means apple and tomato. Okay, so that's why here we're using only 1, let's say neuron. Okay, only 1 neuron, either it will predict 0, either it will predict 1. Okay, and if it is a binary classification, you have to use sigmoid activation function. I think you know sigmoid activation function, right? And if you are having more than 2 category, that means you will be using softmax activation function. Fine. So this is the entire architecture guys I have developed. This is my custom architecture. Now if I show you the summary of my architecture, so this is the summary. Now you can pause the video and you can calculate the parameter. Okay, like why it is coming from this 254 to 127. Okay, why? Because I already explained this part during convolution how it reduced the size, even during max pooling how it reduced the size. Just try to pause the video and try to calculate all the parameter. I already explained this part, guys. I'm not going to repeat again. And that mean of parameter, guys, we are having around 1 crore 48 lakhs 14 crore 8 lakhs, okay, 47,297 parameters, guys, you have to train. Okay, and to train, I mean, that many parameter, you need lots of computational power, and without GPU actually you can't do it. If you're doing in the CPU machine, it will take lots of time. So now let's train the model. So before that, you have to compile the model. In Keras, you have to compile the model. So model.compile, here I'm using optimizer is equal to Adam, and loss function is equal to binary cross entropy, because it's a binary classification. Okay, and matrix is equal to, I'm using accuracy matrix. And if you're having multiple classes, guys, that time you will be using categorical cross entropy loss function. Okay, so this thing maybe you have covered in the deep learning. So in deep learning, this is the like foundation things, like what is optimizer, what is loss function, okay, what is accuracy, everything it is available in the deep learning. Okay, yeah, so now let's try to compile the model. Now once compilation is done, now finally I'm going to feed the data. So let's feed the data. So see, guys, here I'm doing the model.feed operation, and we are passing the training data. Okay, that means training sample, and we are also passing the validation sample. You can see validation sample, validation data. And number of epoch, I'm going to train only 30 epochs. Okay, because here we are having very less images, so I believe 30 epochs it will try to train the entire model. Okay, and whatever artifact it will return, I'm going to send in the history. Okay, history variable. Now let's start the training. See, guys, training has started, epoch is running. Yeah, no coder, right? And real time, you can see the accuracy loss, validation accuracy loss. So this is the accuracy of the training, this is the loss of the training, this is the accuracy of the validation, this is the loss of the validation sets. Okay, real time you can see everything. Okay, so almost training is done. Okay, so guys, you can see execution is completed. So here we got 100% accuracy, training accuracy, and this is the loss of the train. And the validation, okay, you can see validation, I got 70% accuracy, 70% accuracy, and 1 point something, this is the loss. Now can anybody tell me what is the problem here, guys, as per your machine learning knowledge? See, whatever things I'm going to show you, you can execute in the free GPU, but whenever you will be doing the actual production grade training, that time try to buy the GPU. Okay, good configuration GPU, no coder, because just to teach you I'm going to use free GPU. Now what is the problem, guys, with this model? Can anybody tell me? You can see this is the training accuracy 100% and validation accuracy 70%. Overfitting, right? It's an overfitting issue. So let me prove it. So here I can plot in a graph. So I can use matplotlib, and in history dot history, if you do history dot history, let me show you guys history dot history, and you can extract the accuracy like that. Okay, see, this is the accuracy in the number, but it is not visible, so that's why we have to plot it. Okay, we have to plot it. And see, first of all, I'm plotting the training history, that means training accuracy and validation accuracy. Okay, now let me show you. So this is the graph, guys. So this is my training accuracy and this is my validation accuracy. You can see training accuracy is increasing as per epochs is increasing, but there is a saturation point, guys. You can see after I think 15 epochs there is a saturation point. That means there is no improvement in the model. Okay, because it got 100% accuracy that time. And in the validation, you can see there are some zigzag issue first of all, but again it is decreasing. Okay, it is decreasing. That means around 70% accuracy, and there is a gap. You can see it's a huge gap. So I can consider this model got overfitted. Okay, overfitted model. Got it? Now let me also show you the loss with respect to the loss. So here in the history, you also have the loss. So I'm first of all plotting the training loss as well as the validation loss. Now you can see this is the loss graph. So as per training is epochs is increasing, training loss is decreasing, but validation loss is increasing. Okay, and there is a huge gap. So you can consider it's a overfitting issue, guys. Okay, it's an overfitting issue. Got it? Now what might be the issue, guys? What might be the issue because of the why we are getting the overfitting condition? Can anybody tell me how I can reduce the overfitting? Any idea? Okay, no coder is telling add a dropout layer. See, these are the technique we can use to prevent the overfitting. I can add more data because my training data is very less, as you already saw. Then I can apply something called data augmentation. I'll discuss this part. I'll take a dedicated session on the data augmentation. With the help of data augmentation, we can also increase the data. Then we can also perform L1 and L2 regularization technique. Okay, but here I'm not going to use that. Okay, I'm not going to use that. So here either you can use dropout layer, either you can use batch normalization layer, either you can reduce the model complexity, because if you see the model architecture, okay, so it's like very complex model we have created. 3 convolutional, 3 max pooling layer we are using, and 3 dense layer we are using. But as per my data complexity, my model complexity is like very high. Okay, so this is the issue. That means model is so powerful, but data is not that much of powerful. That's why it is getting overfitted to the training data. So maybe we can reduce the model complexity. That means you can maybe remove some of the layer, that is convolution layer, pooling layer, and you can again train. You will see that this overfitting issue would be resolved. Okay, so that's why we are not going to use the custom architecture, guys. Okay, this is the issue with the custom architecture, because you don't know how many convolutional layer, how many pooling layer you have to train for your model. Okay, so that's why we will be using the transfer learning approach. We'll be using pre-trained model. The model is already trained, the model is already built, okay, by the researcher, and this model is already available over the internet. We'll try to download it, and on top of that we'll try to do the fine-tuning operation on top of the training data. Okay, so now I think you got it, guys, why we are not going to use the custom architecture. Yes or no? Tell me guys. Clear? So far everything is clear. Now you can ask me, sir, then why you are showing this training? Because I want to show you how we can train the custom architecture, okay, on the custom data set, because you need to know how things are working in the backend. That's why I'm breaking down the architecture. I'm showing each and everything in front of you. Okay, but whenever we'll try to do the production grade application development, we are not going to use the custom architecture. Instead of that, we'll be using the pre-trained model, transfer learning approach. Thank you. Now let's try to apply some method, guys, because we know that if I'm getting the overfitting condition, so maybe I can add these are the, let's say, technique to reduce the overfitting. So let's try to add the normalization layer as well as the dropout layer in my architecture, because as of now I haven't explained the data augmentation technique. I'm not going to add the data augmentation here. Okay, later on maybe I can show you the data augmentation. That time we'll show how we can perform the data augmentation. Okay, and reduce complexity, you can do it. This is your task, guys. You can also reduce the model complexity. Maybe you can remove some of the layer and you can see the model performance. Okay, so let me add some layer here. So first layer, I'm going to add the normalization layer. Okay, so here what I will do, guys, I'm going to add batch normalization. So first of all, you have to import the batch normalization. So let me import it. It is available in the Keras layer. So batch normalization and dropout, okay, both I'm going to apply. So this is my architecture. And always remember, guys, whenever you are adding the batch normalization, you have to add it after convolutional layer. Okay, after convolutional layer you have to add the batch normalizations. Okay, so then after max pooling, again another convolution, then you can add the batch normalizations. Then again there is another pooling layer, then convolution. After convolution, add the batch normalizations. Okay, so always remember, after convolution you have to add the batch normalizations. Okay, again in the market, like in the, let's say, internet, there are lots of debate whether I have to add the batch normalization before the convolution or after the convolution. There are lots of debate, guys, if you search over the internet, but the actual thing is you have to add it after the convolution layer. Okay, after the convolution layer you can add the batch normalizations. Now we'll be adding the dropout layer also. So dropout layer you always try to add after the dense layer. Okay, after the dense layer, dropout would be applied, and this is the dropout parameter 0.1. This is the default parameter you can take. Now let's define the architecture again. Okay, now again I'll show you the summary. This is the entire summary. Now let's compile the model. Now again let's try to train the model and see the accuracy. So if there is no improvement, that time you can consider this architecture is not best fitted for this for our data. Okay, so maybe you can create another architecture that time. So that's why we are not going to use any custom architecture, because custom architecture we don't know, okay, what would be the best architecture for my data. So we have to do multiple experiment, then I can like figure out my best architecture. Okay, but I don't have that much of time. Whenever I'm doing the project, now I don't have that much of time to experiment the architecture and train it from scratch. Instead of that, we'll be taking the pre-trained model and we'll do our job. That is the idea. So done. Now if I show you my accuracy, now tell me guys, this one is good or our previous one was good? Guys, tell me. I think this one is more bad, right? This one is more bad. You can see the validation accuracy I got 65% right now. But previously I was getting 70% around. Now if I show you the losses, this is the loss. So that means what is our conclusion? Now one step you can do, you can reduce the model complexity, and you can see another one. Okay, so this is your task guys. So your task could be try to figure out the best architecture for this data. Okay, so this should be your task guys. So after the session, please try to create your own architecture. You can do different experiment with different architecture. This should be your task. Unless until you are not doing it, I think your learning would be incomplete. Okay, so I want you to guys explore. I want you to guys write the code. Okay. Even if you get the best model guys, you can also share me. Next session you can share me that model. I will happy to feature in my channel. Okay, that one. Yeah, this work is like a scientist. Yes, because see, researcher also did this kinds of experiment, then they figure out the best model, right, at the end. Yeah. Yes, in general you have to keep on experimenting to get the best model for these kinds of data. Amar. Okay. So how this architecture came guys, because whatever P10 architecture I'm going to use, like VG16, Inception, ResNet, because researcher created the architecture, they trained with the different data like ImageNet data, they observed the accuracy. Okay, then there was a like time they got the best architecture and they proposed as a like pre-trained model. Got it? They proposed as a best model. See, all there is a competition. I told you, na, ImageNet competition. Any researcher develop any architecture, they have to test on the ImageNet dataset. ImageNet dataset. This is the benchmark data, guys. Benchmark data in image classification. Okay. Even if you are creating your own architecture and if you want to publish the paper, you have to train that architecture on ImageNet data, and you have to get the good accuracy. Good accuracy means you have to break all the accuracy so far. Let's say all the models is having their best accuracy. So how I can show you? So let's say if you search like Keras application, so see, these are some pre-trained model. Okay, these are some pre-trained model, and this is the top accuracy, guys. They achieved. You can see exception got 79% accuracy, top accuracy. Then VG16 got 71 accuracy. Then VG19 got 71 accuracy. Okay, now ResNet got 74 accuracy. That's how these are some actually benchmark accuracy they achieved on top of the ImageNet data. Okay, and they train, they publish the paper, they publish this particular architecture so that people can use it. Now, if you are training your own model, guys, if you are designing your own architecture and if you are training on the ImageNet dataset and if you overcome this accuracy, you can also publish your own paper. Okay, you can also publish your own paper and you can claim that this is your architecture. Okay, maybe you can contact with Keras TensorFlow. They will also, let's say, host your model in their, let's say, website so that people can use it. Got it? So that's how research happened, guys. Fine. So guys, you can do different experiment. Okay, I'm leaving to you. So let me show you the next part. So next what I will do, guys, we have done the training. Now we'll try to do the inference. We'll try to do the inference on the test data. So let's say I have an image. Okay, if I want to check whether this particular image is an apple or let's say tomato, how I can do it. So inference with trained model. Inference. So here what I'm going to do, guys, I'm going to upload some image. So let's say I'm going to upload this image. So this is the tomato. I can rename it to the tomato. And maybe I can upload the apple image also. Maybe I can take this one. This is apple. Okay. So first of all, you have to load this image, guys. Okay. How we can load? I think you know that we can use OpenCV for that. So import CV2. And I can read this image. So inside CV2, we are having a function called IamRead. Okay. And inside that, you have to give the image location. So let's say, first of all, I want to load this apple.jpg. I'll give the location of the image. Okay. So it should be a string. So it will load the image and it will return the matrix, guys. Okay, image matrix, you can see. This is the image matrix. Okay. So the image size is 225, comma 3. Okay. And if I show you the image, so this is the image. And again, why it is coming this blue color, guys? Because if you see the original image, so this is red color. And why it is coming blue color, guys? I think I already explained. Okay, whenever I explain the OpenCV. Why? Because OpenCV reads the data in a Bezier format, blue, green, and red. Okay, but the original image, it's red, green, and RGB, red, green, and blue. Yes, you can also convert it to the red, guys. How to? So there is a convert color function you can apply, but here color doesn't matter. Only I need the features. Okay, feature of the image. So this is the shape. This is the shape of your image. So I have to convert it to the training shape, guys, because in the training you use this particular shape. This is the 256. So I have to convert it to 256. Okay. So for this, I can use OpenCV resize. Okay. OpenCV resize test image, and this is the resize, let's say parameter 256. Now this will become 256, guys. Let me show you. Shape. Okay, comma 3. Now if you see, whenever I I have given the data to my model, I have given as a batches. And how many batches, guys? 32 batches. Okay, 32 batches I have given. So I also need to give the batch size parameter. Okay, batch size parameter, because as of now there is no batch size. So how many images I'm having, guys, in the test data? Only one image. Okay, that's why I have to give one batches. See, test image reshape 1, then 256, comma 3. That means this is the batch parameter, guys. Okay, batch parameter. So whenever you train the model, you have given 32 batch. 32 batch. See, 32 batch. Okay, batch size 32 batch. Now here only you are having one image, that's why one batch. So this parameter you have to give, otherwise it will throw error, guys. Okay. Now we'll try to pass this data to the model.predict, and where we are passing the input data, and this is the results. Now it is predicting, guys, what? Tell me. 1. And what 1 represents? Tomato. So this is doing mistake, guys. So let me take another image. I think that would be fine. So inside apple, because I am having very less images now, that's why. So I'll copy this path, and here let me mention it. And again it got overfitted. Okay, that's why it's doing some mistake. Now this is the apple. Now again, if I do all the operations and if I predict it, Again it is 1. So let me take another image. Let me take this one. Copy the path 25. This one I think. Copy the path. You can mention it here. Okay, again it is 1. Okay, because of that problem, guys. Okay, overfitting problem, it is predicting as 1. Now if I give tomato image, copy path, tomato should be 1. See, tomato should be 1 because tomato has assigned word 1. Okay, now here you can write a condition. If your results, okay, you can see this is the result is a it's an array, numpy array, 2-dimensional numpy array. That's why we're extracting that the 1. Okay, and we're converting to the integer. So if it is equal to 0, that means it's an apple, otherwise it's a tomato. Now if I execute, it's a tomato. Okay, maybe I can take another apple. Not this one. So let's take this one, guys. 56. Copy path. Let me give it here. Load it. Okay, again it is coming 1 because see, it got overfitted. So that's why, guys. Okay. Yeah, so you can improve the model. Definitely it will able to predict that, because see, here my intention is to show you the training process. Okay, how training can be done. And this custom model we are not going to use at the end, because this is the problem you will be getting at the end. You have to fix the architecture, then you will be getting the expected output. How about we test the green and red ball? So for this you have to do the color detection, Amal. Okay, color detection. So color detection is a different thing. So guys, tell me, guys, overall experiment, did you understood? Everything is clear? Tell me yes or no. So till model from model training I showed you till inference. Okay, how to do the single image inference also. Clear? Tell me. See, very bad accuracy, nah, that's why. Very bad accuracy, and at the end this apple and tomatoes are almost same, that's why it is getting confused also. So maybe previous model will work better. Okay, so after before applying this batch normalization and dropout, it was giving me 70% accuracy. That model you can try, maybe it will work. So I mean passing the green and red ball image to this model for experiment. A ball image, see, ball image you don't need to give because here you have trained with apple and tomato, but again maybe it will categorize as a like tomato or apple, like that. Yeah, but for ball image training you can use ball images. Okay, that time. So guys, clear? Let me know. Are you clear? And I will share this code with you. You can try. So what would be your task, guys? Just try to improve the architecture. This architecture. See, there is, I mean, no resources that you can follow to make the custom architecture, because at the end it's a completely research field. Okay, you have to create hundred of architecture. You have to train it on the custom data, and you have to observe the accuracy at the end. Okay, this is the work. Amal. So guys, clear? Let me know how was the session. How was the session? Did you like the session? It was informative. Please tell me which GPU is the best. If you are using Collab, so you can take this GPU, guys. A100. This GPU is good. Okay, A100, but this is the premium one. You have to purchase that. Yeah, thank you guys. Now you can just try to improve the architecture and let me know after, let's say, if you get the best architecture for this data, let me know. Next session I'll try to definitely feature your architecture. Okay. Physical. Okay, physical, like it depends upon your price range also. At least you can consider I mean RTX 3050. Okay, at least it should have 12 GB VRAM somehow. No, next class we'll try to explore different thing. Okay. I need, I think, one to two class more to complete some basics of the CNN. Then I will start with the transfer learning. That means this kinds of pre-trained model Amal. Okay, ResNet VG16 will be taught also. First of all, I also need to cover the backpropagation in CNN, then how CNN works. That means, let's say, these kinds of training we have done. So internally, how it is identifying the features. I want to show you the visualization. Okay, each and everything I want to show you. Yeah. So see, this series would be completely detailed series. Okay, here I'm not going to skip anything. It would be completely detailed series. And these kinds of series, I think you won't be getting anywhere so far. How to send the architecture to you? See, this is my email. Let me share my email. You can send it here with your name. Yeah, you can send it here with your name. Otherwise, you can also send to my LinkedIn profile, guys. So this is my LinkedIn. So I'm giving you the link in the chat. You can also follow me here and you can connect with me. You can send it also here. Even you can also send in the YouTube chat comments. Okay, so from there also I can see that. So YouTube chat would be fine, guys. If you send it real time, I can see all of your experiment. Okay. Yeah, so if you like the session, guys, please hit the like, all of you. If you like the session, please hit the like. And if you haven't subscribed yet, guys, please try to subscribe to my channel. So my target is, guys, very soon we'll try to hit 50k subscriber. Is it possible? Yeah, and one thing, guys, I created a Telegram group, guys, for you. Let me send a link. See, I got lots of questions like, sir, how we can join inside a group so that we can do the discussion, right? So I created a Telegram group, guys, for you. So this is the Telegram group link, guys. Okay, this is the Telegram group link. So I will also add in the in this notebook. Join my Telegram group. Okay, and here is the link. And this link would be also available in the description section. Okay, in the description section, the link would be also available. From there, you can join the Telegram group. I don't use Discord, Amal. Okay, so that's why. Okay, Telegram is banned in Pakistan. Okay, you are from Pakistan. That's why. See, if you are from Pakistan, so see, I don't use Discord actually. Okay, I'll think about. First of all, try to join in the Telegram group. Discord also I'll try to create. Okay, after installing the Discord, because I don't have the Discord right now in my system. Okay, after creating it, I will share with you. As of now, you can join the Telegram, guys. Okay, yeah. So link I have already shared, and this link is also available in the notebook. Even I will also mention in the description. From there, you can join in. Okay, so many people are joining from Pakistan. Okay, definitely. Okay, so thank you guys for joining the session. So let's connect in the next session with a new topic. And always remember, consistency is the key, and try to practice a lot. Okay, always practice will make you perfect. Okay, I'm only just like a mentor. I can only give you some information, but at the end, if you want to be like pro, definitely you have to practice a lot. Got it? And if you need anything, guys, from my side, let me know. Try to support my channel. So let's hit 50k subscriber, guys, as soon as possible. And definitely, I have very big plan in my channel. I'll bring all kinds of playlist here. Okay, in detail playlist. Thank you, guys. Bye, everyone. Good night. Thank you.